So now let's look at how we actually do the lab. I'll do row one object down and show you where your measurements go. So the first thing I'm going to need is to measure my HO, and then I'm going to measure my, actually this would be my H1, this is my HO, and that's going to go in the table right here. We're going to measure our taller height and our second height, and our delta H is the difference between them. So here I'm measuring my H1, and then I'll measure my H2 and put them in the table as I just showed you. Then I also need to measure the distance from this tape to this tape on the board. So I measure that distance, and that distance is my delta X. So that's going to be my delta X here that I measure. I'll get my delta T, obviously my mass and my radius. I don't need, you know how to put the mass, the object on the scale, and your radius, you just take a ruler and measure that. You'll need to measure that also. So now the lab itself is simple. We've done it dozens of times. I'm going to use my video physics. I'm going to use my ruler yardstick so I can get a good initial time. And all I really need to, I've already measured physically the distance, so all I need is the time from here to there. So I let it roll, I measure that time. Then I will do that with each one of these objects. I think you can follow along from your picture of the notebook. I don't think we need a separate notebook instruction. It's kind of already, it's self-explanatory. You guys do a good job at that. So I measured my H0 and H1. I really should have put those values right here, okay, because I did the large disk. You notice your delta H will not change. That will not change. Your delta X will not change because you will use the same ramp for the whole time. Then I measured these values. I calculated I. You can see that on the previous page. This is all one table. I calculated V bar, multiplied by 2, got V, and then I used my equation to find my omega. Then from there I can calculate my potential energy of gravity, my rotational, my linear, and I had my total. These two should be the same. Okay, technically this change should be negative. So if you want to put a negative here and add those together, my change, I actually, according to this, I wound up getting more kinetic energy out than I put in. That's probably partly just due to rounding errors from where I rounded to 2 decimal places. So that gave me 103% efficiency, which we know is not correct, but it just means it's probably really close to 100%, and I was off just a little bit. Make sure down here you do problems, question 12 and 13, that you answer those. I didn't write the names down because then that would spoil your fun, because they want to know which one of these objects has the biggest and which has the smallest rotational kinetic energy and linear kinetic energy. I think that'll do it for you. Good luck.